Hi, my name is Neil Joshimpule, and I'm bringing you this presentation on approaches to load testing website databases with Microsoft SQL 2008 R2. This is actually a mainly theoretical lecture since I left the code and the components of what I had done at work. Okay, so let's first start off with what is load testing. Load testing is the process of putting demand on a system or device and measuring its response. Load testing is performed to determine a system's behavior under both normal and anticipated load conditions. It can identify the maximum operating capacity of an application as well as any bottlenecks and determine which element is causing degradation. When a load is placed on a system and raised to the point where the system fails, this is caused stress testing. I got this definition from Wikipedia, and I think it's pretty clear as to what it means, so I used it. Okay, so for me, when I'm load testing, although there's several ways people approach load testing and stress testing, I've used two approaches, the website-based approach and the database-based approach for testing out the database. What I find is that the website-based approach isn't a good indicator of testing the database, since your web server has the potential to fail before your database will get overloaded. Consequently, I don't use the website-based testing very often. What I do is use it to see the point at which my web server will fail. The database-based approach is what I normally use. The website-based load testing will also have additional latencies, like the network latency, as well as any communication latencies between the website and the database that must be tagged on to your database lag time. So the database-based load testing tends to be a better indicator of this. Below here in this slide presentation, I show you the setup of a load tester. I have four main components in any load tester that is used. The first is a traffic simulator. This will generate traffic or user data and push it into the database and interact with the database continuously. So with the traffic simulator, you can specify how much traffic and interactions are occurring with your database. And then based on these interactions, I will collect database performance information with a data collector, which in my case is SQL Profiler. And I will put the information that SQL Profiler reads into a database table or even files, and then I will extract that data and process it into graphable data using a data processor. While I am showing you how to build an actual load tester and all the components in it, there are UIs that already exist that have the capability to do this. One example would be SOAP UI, and I believe that Eclipse and Visual Studios also have built-in facilities to load test your database. So this is just one approach to load testing your database, while there are several options that exist out there. Okay, so the two approaches I'm going to describe right now are the website approach and the database approach. When dealing with the database, with the website approach, you have to consider the web server latencies as well as network bottlenecks. And when dealing with the database approach, or even the website approach also, with SQL Profiler, it'll watch out because in times I have seen it overload. So what you have to do is, in order to get by that, you cannot use the SQL Profiler UI. You have to run SQL Profiler in the background using SQL commands. or SQL Server custom commands that will start it off from in the background rather than having it go through a profiler user interface. So the website approach has three main parts. It uses SQL proc, the SQL profiler, of course, to gather data, and a JavaScript web a client application that will actually call particular activities on the website and simulate user activities. So you make basically, when I did this, I made a JavaScript program that would simulate user browsing. The database approach uses batch files. The batch files are used to run SQL procedures in parallel, and you'll use profiler to gather up the information. So let's go next. Okay, so with the website load tester setup, as I said here, you had to watch out for network latencies and IIS servers. Latencies, the way I did this is that I would use a web server, a website. I would make a JavaScript program that would basically, I made a JavaScript program that basically simulated user activity by firing off a web service, which was a web crawler, and the web crawler would browse the site as a user, and as it browsed the site, it would trigger database activity, since the website was a database-based website. So based on how many web services I fired off at a time using the JavaScript program, it would simulate high or lower amounts of traffic. What I found is that the web service tended to fail because it would get overloaded before the database could really even see a faint amount of activity. So that was like, however, it did give me an idea of how much load a particular web service could take. Also, when load testing, you had to take into consideration the processor speed, the amount of RAM you got, because really its performance, the database's performance and web server performance is based on the machine you're using in order to run it. Okay, so now let's get to the load tester that worked and is reliable. So basically, using SQL proc, you're going to simulate user activity. You can either use SQL profiler to record all database activity and rerun it. SQL profiler has that functionality. You can just Google it, and what you need to do based on the database activity that you're simulating is gather the read and write times from profiler, the block times, and the deadlocks. Let me show you how to do that. So as you can see here, when you go to trace properties under SQL profiler, you have the option of choosing blocked process reports. This will give you the amount of blocks. You could also look at deadlock chains. So this, for every deadlock process that leads to a deadlock, this will fire off an event. And to get the read and write times and the duration of a particular query, you can use the batch completed and the batch started. In my particular load test, I was load testing a procedure. So what I did is I used a column filter to pick out that procedure that I was looking for. So I would look text data. Now it's set up a procedure to that I was testing, and I would fire that off directly. I would save the data to a file in based on the trace properties, and then I would, or to a table if you want, and that would be the raw data from SQL Profiler. Based on the raw data, I would have recorded the read times, the write times, the blocks, and the deadlocks. In order to use the blocks and get block data, you got to remember you got to set up the block process threshold in SQL Server, because blocks occur for multiple amounts of time. So if you need to set up how long you want a block to hold before it fires off an event. So this is in seconds. So you use the sp_configure process and set the block process threshold, and I set it to 20 seconds here, and then reconfigured, and that stores it in the database. Okay, and so basically based on the data from SQL Profiler, you're going to get 4 graphs, one for the read times, one for the write times, one for the blocks, and one for the deadlocks. Based on how much traffic you have, and you'll see, assume that for this graph that I'm showing on the screen, that the x-axis, which is the bottom axis, is the number of transactions and that are fired off, and the y-axis is the write times, the read times, the number of deadlocks, and the number of blocks. So what you can see here is that initially SQL Server will handle the load properly. So the number of transactions will go through, and it'll as you increase the amount of load, the write times and the read times and the number of deadlocks and the number of blocks will increase at a steady rate. However, at one point you're going to see some oscillation here. That is when the SQL engine is approaching its overload state, and it can't handle any more data. So it'll try to handle it, and you'll see some alterations with high load of parallel transactions. Eventually you're going to see it plateau, and that is because of the SQL engine will be flooded, and at that point your engine will slow down exponentially. The amount of read and write times will increase. At the plateau point you're going to get deadlocks, while SQL Server could handle the load up to the point where the database is overloaded. You're not going to have any blocks or deadlocks, but I found that when it plateaus, suddenly you're going to get tons of blocks and tons of deadlocks based on your block threshold. And then it will eventually plateau. So as you can see, the plateau is where the SQL engine is getting overloaded for a particular amount of traffic. Since each script in SQL is actually a serial operation, you have to use a batch file to fire off SQL operations in parallel. The reason for this is because SQL, you can't, by running a proc in a query window, you can only have it running serially. So by using a batch file, you could fire off multiple queries at the same time. I hope that was clear. If not, feel free to ask questions, and I hope it was helpful or gave you a little bit of an idea as to how to approach load testing. Remember to run SQL Profiler in the background, and that is all for now. Thank you. Bye.